Hey, welcome back to the notes for Common Core Algebra II. Today's lesson 11.4, sine and cosine of the unit circle. So the sine and cosine functions form the basis of trigonometry. We would like to define them so that their definition is consistent with what you already are familiar with concerning right triangle trigonometry. Recall from Common Core geometry that in a right triangle, the sine and cosine ratios were defined as the sine of A is the opposite over the hypotenuse. So the sine is the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse. So hopefully you mastered that last year when you were in geometry, because that's going to come back again when we talk about the unit circle today. All right, so exercise 1, consider the unit circle shown below with angle theta, drawn in the standard position. Well, here's theta right here. All right, so here, from here to here, is our theta. All right, so given the right triangle shown, find the expression for sine theta. So if this is my triangle, right, so I'm just going to, let's complete our triangle, which is right here. All right, so the opposite side for theta is going to be sine theta is equal to the opposite side, which is y, divided by the hypotenuse, which is 1. So therefore, sine theta is equal to y. So whatever this point is right here, this y right here is going to be sine theta. So given the right triangle shown, find the expression for cosine theta. I'm just going to slide this down just a little bit so we still have our unit circle in our sight. And we're going to do the same thing now. So cosine theta is equal to the adjacent side in this case, which is x, over our hypotenuse, which is 1. So therefore, cosine theta is equal to x. So this right here is our cosine theta. So any point on the unit circle is going to be the cosine of the angle that it makes, sine angle that it makes. Now, some people always get that mixed up because we're always thinking about sine, cosine. But I always think about it in alphabetical order because cosine C comes before sine S. So the cosine is the x value and the sine is the y value. So that's just a little way I remember which one goes where. So we thus define the sine and cosine functions by using the coordinates on the unit circle, like I just talked about. They are the first functions that are geometrically defined as they are based on the geometry of a circle or circular functions. So this is just what we talked about. The definition of sine and cosine functions is for an angle in standard position whose terminal ray passes through the point xy, and that's exactly what we just set up. If you consider that unit circle that we looked at, okay? And an angle in a standard position means that one of the rays sits right here at the x-axis between quadrants 1 and 3, and the other angle ends up somewhere on our circle. So it could be here, and then this would be the point xy. It could be over here, so this would be our angle, and this would be our xy. But it doesn't matter. Whatever our x comma y is, what they're saying is the sine is the y coordinate, and the cosine is the x coordinate. Sometimes I like to say cosine theta, comma, sine theta when I think about my point on the unit circle. So this definition is unquestionably the most important fact to memorize concerning trigonometry. We can now use this along with our work on the unit circle to determine certain exact values of sine and cosine. Now, sometimes you'll be asked for exact, which means that we need these certain angles to find those exact values. When you don't have certain angles, you're going to have to use your calculator and then estimate or approximate your angles based on what your calculator gives you. And we'll talk about that a little bit later. So exercise 2 says, using the unit circle diagram, determine each of the following values. Now remember, your unit circle value diagram is coming from the lesson prior to this one. So you should have this at home. And if you don't, you can actually get it online if you want a copy of it, or if you want to just look at it. But a sine of theta, a sine of 30 degrees, if we remember, you know something? Why don't we pull it up? Okay, so there we go. So using our diagram, I know this looks a little different than the one that we created together, but using this one, what's the sine of 30 degrees? So if we take a look right here, we can see that 30 degrees sits right over here, all right? 30 degrees, and we know the sine is going to be the y value, so it's 1/2. So B says the sine of 240 degrees. So 240 is down here at the bottom. And again, sine is our y value, so it's negative. I'm running out, I'm just going to put it here, -3/2. Now I'm going to do E and F if that's okay, because then I'll slide my diagram over. So the sine of 90 is all the way up here. Sine of 90 is 1. And the sine of 135, here's 135 in the second quadrant, and my sine is going to be radical 3/2. So this is just strictly coming off of our unit circle diagram. Which you guys should have with you from 11.3. Now, hopefully I should be able to do this and move this over. Oh, alrighty, so let's do our other problems now. The cosine of 90. So these are all cosine problems. So cosine means we're talking about the x value. So the cosine of 90, here's 90 degrees, cosine of 0. Cosine of 180, which I can't see because it's too far over. Cosine of 180 is going to be -1. These are x values, remember. Cosine of 150, 150 sits right here. X value, -3/2. Rad 3/2. And the cosine of 0 is 1. Now these three, this one, and this one, can also be gotten from your calculator. This one is going to give you an approximation on your calculator because it's going to give you that -rad3, which is negative approximately 1.732 divided by 2, which is approximately 0.866. So it'll give you an approximation, but when it asks you for exact values, that means it wants the radicals, okay? So hopefully that wasn't too difficult for you. And now we can move on to exercise 3. The terminal ray of an angle alpha, drawn in standard position, passes through the points -0.6, 0.8. Now, can we figure out what quadrant that is? That's not what the question is asking us, but I always like to visualize where my angles lie. So if I have a negative x value, I have a positive y value. A negative x value means I'm moving in this direction, and a positive y value means I'm moving in this direction. So a negative comma positive is going to be right here in the second quadrant. But that's not what the question's asking us. It's asking us which of the following gives us the value of sine alpha. Now sine is going to be our y value, so we know the y value is positive, so we know that 3 cannot be the right answer. So we know that it's going to be 0.8 in our answer, so there we go at number 2. So it is important to be able to determine the sign, whether it's positive or negative, of each of the two basic trigonometric functions for an angle whose terminal ray lies on a given quadrant. All right, the next exercise illustrates this process. Now, this is the way I kind of like to think about it. So it says for each quadrant, determine if the sine and cosine of an angle whose terminal ray falls in the quadrant is positive or negative. So I remind you here that it's going to be cosine, comma sine. So more specifically, it's cosine theta, sine theta. So this is kind of what I was just talking about with the last exercise here. So if you look here in the first quadrant, if you have an angle that lies here in the first quadrant, you can see how the first quadrant, the x value is going to be positive and the y value is going to be positive. So the first quadrant gives me a positive and positive, which means that my cosine is positive, and my sine is positive. When we move here to the second quadrant, I know that my x value is negative and my y value still remains positive. So my x value is negative, my y value is positive, which means that my cosine is negative, my sine is positive. Moving down to the third quadrant, my x value is negative and my y value is negative. So anything that falls on this point here is going to be a negative, comma negative, which means my cosine is negative and my sine is negative. And the last one is our fourth quadrant where my x stays positive, my y remains negative. So here it's going to be positive, negative, which means my cosine is positive and my sine is negative. Now that's kind of important because when we start dealing with finding exact measurements, we're going to be using reference angles and this information in order to determine the exact value. Okay? So exercise 5. Since each point on the unit circle must satisfy the equation x squared plus y squared equals 1, we can now state what is known as the Pythagorean identity. So we know that the cosine squared theta plus sine squared theta is equal to 1. And that comes directly from right here, because we know our x is our cosine, right? So we have whatever cosine theta is going to be our x squared. Whatever our sine theta is going to be our y squared, and it's equal to 1 because the unit circle has a radius of 1, and 1 squared is our right-hand side of our equation. So in exercise 5, so this is our identity right here. This is going to help us enormously. So an angle alpha has terminal ray that falls in the second quadrant. So the first thing I like to do is kind of draw myself out. I mean, you can consider doing the unit circle, but what they're saying, it lies here in the second quadrant, right? If it is known that sine alpha is equal to 3/5, determine the value of cosine alpha. So we know that sine, and this is generally how you write it, sine squared theta plus cosine squared theta is equal to 1. Well, sine squared theta is 3/5. So square that plus, and let's call cosine squared theta, why don't we call that x squared is equal to 1. Because we're solving for what the cosine, that's what it wants here. Not cosine squared, it wants to know what cosine is. So when you square a fraction, you can do this in your calculator, square the numerator and the denominator, plus x squared is equal to 1, minus 9/25, minus 9/25. And again, this can easily be done in your calculator, no flipping out. X squared is equal to, remember we need common denominators. This is 25/25 minus 9/25, which is equal to 16/25. Take the square root of both sides. and x is equal to negative, I'm sorry, 4, I was going to say positive and negative, so 4 over 5. Now the reason it can, remember when we took square roots, it was always going to be positive and negative of the square root, but because we're talking about sides and angles, we're only talking about the positive value here. So our answer is 4 over 5. So make sure you answer the question. The cosine of alpha is equal to 4 over 5. Okay. We have one more exercise to look at, which is very similar. In exercise 6, an angle theta has a terminal ray that falls in the first quadrant. We know the cosine theta is equal to 1/3. Determine the value of sine theta. Now this one says in simplest radical form. So we want to know what sine theta is, and we know that cosine theta is equal to 1/3. So we're going to go back and use our identity. Sine squared theta plus cosine squared theta is equal to 1. Well, we're looking for some, so why don't we let x equal sine theta. So we have x squared plus 1/3 squared is equal to 1. X squared plus, and you square this, it becomes 1 over 9 equals 1. This is called an incomplete quadratic. You can solve it like a linear. So you get x squared is equal to, remember, get common denominators. You can do it in your calculator. So you get 8 over 9. And now you have to make sure, don't forget this last one. You have to take the square root of both sides, so we're solving for x. So x equals the square root of 8 over the square root of 9. Now the beautiful thing is here, the square root of 9 is 3. But that square root of 8, just come up here for a second. Do you remember when we did the square root of 8 and we had to simplify this because it says simplest radical form? We broke it into perfect squares and what was left over. So this is going to be 4 times 2. And the square root of 4 is 2 times the square root of 2. So I have to write this as 2 square root of 2 over 3. So make sure, again, you answer the question. Sine theta is equal to 2 rad 2 over 3. We're really trying to take some baby steps here by doing these. All of these lessons could be really consolidated into one lesson, but because it gets confusing, we thought it would be easier for you if we just took it step by step. All right, and we'll continue on with this. We're going to have a day 2 of this tomorrow with 11.5, and hopefully that's going to show you a little more clarification when it comes to those quadrants and our exact values. Okay, until next time, be kind to each other, okay, and make good choices.